This question now is related to rates of change. The volume of a sphere is increasing. At the instant where the sphere's radius is 0.5 meters, the surface area of the sphere is increasing at a rate of 0.4 meters squared per second. Now we have the equation for the volume and surface area of a sphere here. Notice that they are all related by the radius. So if we differentiate these values, which is dv over dr, we get 4 pi r squared, and if we differentiate the surface with respect to radius, we get ds over dr. In the question it says we must find the rate at which the volume of the sphere is increasing. That means that we need to find dv over time. Using the derivatives that we already got here, which is dv over dr and ds over dr, we can set up a chain rule equation to find dv over dt. Please note that we get ds over dt from the question here where it says the surface area of the sphere is increasing at a rate of 0.4 meters squared per second. We need to find the inverse of ds over dr in order for the values to cancel out so that we have dv over dt. Notice here the ds cancels out here and dr cancels out here, and we're left with dv over dt. Finally, we plug in the values that we have so far. ds over dt was 0.4. dr over ds is the inverse of 8 pi r, which we have written here, and dv over dr is written here. We finally get 0.2 r, and we need to find it when the radius is 0.5 meters. So we plug in 0.5 meters in the r, and we get 0.1. Finally, the answer dv over dt is 0.1 meters cubed per second.